Hey mathletes, Dave Stoblin here. We're still talking measures of dispersion. I would like to talk about another measure called standard deviation. Now, we previously talked about range, which is the largest value in the data set minus the smallest value in the data set. And while that tells you how far apart the data is from smallest to largest, it's not necessarily the best measure to describe how the data is spread out. And so standard deviation is a better measure because it represents the typical or average distance from any data point to the mean. All right, so let's talk about this. Now, before I tell you more, I need to explain that there's actually two different types of standard deviation. Okay, now to understand what they are, I'm going to draw a picture of the lower peninsula of Michigan. So lower, oh my goodness, I'm breaking pencils left and right. Lower peninsula of Michigan. Okay. Now, if we counted up all the people in the lower peninsula of Michigan, we would have the entire population. Okay. Now, we could count everybody in the entire population, but let's say we wanted to find out what their favorite movie is. It would be hard to talk to everybody. So what we could do, instead of talking to the entire population, we could take a sample of people out of the entire population that represents the entire population. So we could take a sample from the population. Okay? So we have a mean, which we represent by x bar if we're talking a sample from a population. But if we're talking the entire population, we represent the mean using the Greek letter mu, which looks like a letter U with a long tail on the front. The standard deviation for a sample from the population, that would be a small group of people from the entire population, is represented with a capital S. And if we calculate the standard deviation of the entire population, we represent that with the Greek letter sigma, which looks like that. Pretty crazy. All right, I'm just going to stop there. We are going to learn more about this later, but I just need you to understand right now that sometimes you have an entire population, sometimes you have a small group or sample from the population. Depending on which you have, you represent the mean and the standard deviation using different symbols. Okay, so let's calculate the standard deviation for a set of data. And I am going to go back to my favorite data set, data A. And you will recall that data A was 48, 49, 50, 51, and 52. Okay? Now, there's a few things that we have to do to calculate standard deviation. And the very first thing we have to do, number one, is we need to find the mean. And so what we're going to do is we're going to sum all of these data points, these x values, and when we do that, we get 250. 48 plus 49 plus 50 plus 51 plus 52 is 250. Then we need to know how many data points there are, n, and there's 5. So calculating the mean, and we're assuming that it is a sample because we're using x bar, we would do 250 over 5, and the mean is 50. Okay? Now the next thing that we have to do is we need to find the deviation. And the deviation is the distance, I'm going to go up here, it's the distance from any data point to the mean. So the way we do that, it's the distance of any data point to the mean, and we can do that by subtracting. So the first thing we do, the first data point x is 48, and the mean is 50. That's -2. Then the next data point is 49, and its distance from the mean is -1. The next data point is 50. Its distance from the mean is 0. The next data point is 51. Its distance from the mean is 1. And the last data point is 52. Its distance from the mean is 2. Okay? So those are all the distances from the mean. And now what we have to do is find the average distance from the mean. So if these are all the distances from the mean, we need to find the average of these distances from the mean. There's a problem, however. When you add all these up, you get 0. And that's not going to work. And the reason is because these distances are negative and these distances are positive, and they cancel out. So what we want to do is we want to get rid of these negatives so that we have just the distances without the direction of positive to the right or negative to the left. So step number 3 is we have to find the deviation squared. So that's going to be x minus x bar squared. So -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay? Now we can sum up these deviations squared. So 4 plus 1 is 5, plus 1 is 6, plus 4 is 10. And now we can calculate the standard deviation, and this is going to be for a sample. So S equals. Now, here's what we did. We found the distances and we squared them to meet them all positive. So we are going to take these numbers, which is x minus x bar squared, and we are going to divide them by the number of data values, 1, 2, 3, 4, 5, which is n, except because it's a sample, you have to subtract 1. And then, because we squared these things, we have to unsquare them with a square root. That looks absolutely horrible. But we've already done the math. We know that the sum of x minus x bar squared is 10. We know there are 5 data samples minus the 1. And we can take the square root. You can do that on your calculator. It's 1.58. Okay? Now, here's the very last thing. Remember, I said this was for a sample. We did x bar and we did s. That's for a sample. If it's for a population, x bar and mu are the same. The mean is the same for a sample and a population. The standard deviation, however, is just a tad different. It's still the square root of the sum of the deviation squared, but instead of dividing by n minus 1, we divide by n. So in this case, it would be 10 divided by 5 square root, and it comes out 1.41. Again, I understand that this is absolutely horrible. Do your best to understand, and know that deep in your heart, you will never have to calculate this by hand. You will be able to use your graphing calculator, and that's going to be a wonderful thing. So when we talk about this in person next time, make sure you have your graphing calculator, because it's going to be way easier than doing this by hand. You just heard my cuckoo clock, which means it's 9 o'clock at night and it's my bedtime. So let's call this enough. I hope you enjoyed standard deviation. You probably didn't, but do your best. Talk to you later.